Hi everyone. So this is Dr. Richard L. Figueroa. So I'll be handling the graduate school optimization technique class. Okay, so for engineering management. So this would just be a brief discussion or an introduction of optimization techniques. So this would be our course outline. So I'll start with the introduction to quantitative methods, so which I'll be discussing in a few moments. And then, so we'll start with linear programming. So using, we'll just recall, okay, so some of the simplex methods as well as graphical. So simplex method for maximization, and then we have the big M method for minimization problem. And then we'll proceed with integer programming. So similar with linear programming, so we're just limited with integer numbers. So we have nonlinear programming as well as dynamic programming. And once we are done with that, so we'll proceed with network analysis, so game theory as well as decision theory. So this would be the course outline. So for our meeting, okay, so for this module, okay, so for the entire module. And these are the course requirements of for this course. So we have, so since this is more on solving, okay, or problem solving, so we have some practice problems. So where you will be given practice problems and then you solve. Okay, so you solve the problem so based on what was given. And then afterwards, so we have research task as well. In this case, so you will be given a case scenario, and then so from there will be some series of questions that you are going to answer. So based on the results of your or based on your findings, using the different problems that were provided to you, and it would be in a form of a research type. And then afterwards, so we'll have the final exam. So these are the course requirements. So for GS Optech. And for our reference, although there are a lot of available resources, okay, so for quantitative analysis for management, so we will be in particular, so with the book of Barry Render, okay, so which for the quantitative analysis for management. And as I mentioned, so we'll start with the introduction to quantitative methods. So this would be the outline. So we'll try to define so what is quantitative analysis, and then what would be the approach. Okay, so for quantitative analysis, and lastly is how to develop a quantitative analysis model. So this would be the basis of the different techniques that we will cover. Okay, so for the entire term in engineering management, okay, or even in engineering as a whole, okay, there are different systems, okay, so that can be uh, represented through a mathematical model, okay. So this mathematical model so would give us an insight, or will give us an idea on how a certain system works. And through mathematical modeling, okay, so through mathematical modeling, so we'll be able to understand how that system works. Okay, so whether that will be a mechanical system, okay, or whether that would be in a production system, everything, okay, so it can be represented into a mathematical model so as to give us an idea, okay, so how the system works, okay, so how the processes works. However, the mathematical model in itself will not be useful unless otherwise. So there would be some quantitative analysis that will be involved. Okay, models are good. Okay, so to represent a certain system, but the model itself is unuseful unless it is paired with a good quantitative analysis. So that is why it is not just enough to know the mathematics of a given technique, but rather we should know how to properly apply that mathematics. So that is the quantitative analysis. So knowing mathematics is first, okay, so that's the first step. However, applying these techniques into real world applications or real engineering management applications, then that what makes the quantitative analysis is. So let's try to define what is quantitative analysis. So quantitative analysis is a scientific approach to problem decision making in which raw data are processed and manipulated to produce meaningful information. So quantitative analysis is based on raw data. Okay, so based on actual data. So that is it's very important. Okay, so to have a very accurate actual data, and based from that actual data, so we'll do apply the analysis. Okay, so manipulation of that data. So through mathematical representation and later on through analysis, that would make a meaningful information afterwards. So decision making uh, is best achieved. Okay, so once we have an accurate data. Okay, so through the process of quantitative analysis, so through proper interpretation of the mathematical model, and then analyzing what does it mean, so that would give us a meaningful information or a meaningful decision. Okay, so a meaningful decision that is based on facts. Okay, so that is based on actual data. Okay, so decision should not just be based on guts, okay, but it should be based on actual data. So thus it will arrive to an informed decision that could be beneficial, okay, so for everyone at stake at it. And in quantitative analysis, so there are quantitative factors, okay, so in which, okay, are the basis, okay, so which are the basis in making an analysis, okay. The first one would be it could be different investment alternatives, okay, so whether like for example, if I would have this amount of money, okay, will it be good if I am going to invest it in stock or in stock exchange, or am I just going to be or am I just going to invest it in the bank? It depends. Okay, so if of course a high risk, okay, so a high risk, so will result to a higher profit, but a low risk, okay, so it could be a lower profit, but it's much more, or it's more secured. So deciding so where to properly invest, so could uh, be or we could arrive through a certain decision, okay, so that would be best for us, so once we apply, okay, so techniques, okay, so for quantitative analysis. So the other one, so we could have the interest rates, okay. So for the interest rates, like for example, if I'm going to get a car, okay, so will it be good if I am going to have an enhanced finance or an in-house finance, okay, so from the car company, or will it be good if I am just going to have a loan or a car loan from a bank? Okay, so for the interest rate, so which one would yield a lower interest rates for me? Okay, so most of the time that would be from the bank, as long as we have a good credit from the bank. So usually the in-house, okay, so would have a larger interest rates as compared to the banks most of the time. Then we could have some inventory levels. Like for example, if I am on a production line, and then I want to maximize my production output. Okay, so for me to arrive through a certain decision, so whether I'm going to produce this product A over the product B, so I have to check my inventory. Okay, so I have to check my inventory. So how many resources do I have? Okay, so to produce this product A over the product B, and are using the principles, okay, of quantitative analysis, so we'll arrive, okay, through a certain decision, so that could optimize the profit, so given my inventory level. The other one, we could have, that's the same as true for the labor cost. Okay, so if I want to optimize, okay, so if I want to optimize the use of a certain machine over the traditional one, so I could make an informed decision, okay, so through optimization techniques, so through linear programming, so whether it will be beneficial if I'm going to use this one machine over the other machine, because operating this machine so would entails this labor costs as compared to the other. And lastly, so for the demand, so let's say if I am producing, so let's say three types of medicines, and then I want to have an optimized output. Okay, so which one will yield the highest profit? Okay, so probably I could check, okay, through a market, or I could do some market study. So for me to determine what will be the demand for the different types of medicine and other factors, okay, so that could affect the profit if I'm going to produce this different type of medicines. And again, the simple method there would be through a decision tree. So I'll be able to make a decision, so whether I'll push through, okay, so with this type of medicine over the other. So all of these things are the quantitative factors, so which affects the decision that we will arrive to, and we could arrive through that decision. So once we do some quantitative analysis, so through mathematical modeling, and afterwards, so analyzing the data, so based from the mathematical model that we use. And although the previous factor that were mentioned, those are quantitative data. Okay, so those are data that can be measured, or those are data that can be calculated. However, there are some factors as well, so which affects decision making. However, it's so very difficult to quantify those factors, but it affects. Okay, so it affects the production line. Like for example, the weather. Okay, so probably I'll have these raw materials. However, because of a bad weather condition, okay, so that material will not arrive. Okay, so that's a factor. Okay, so that we need to consider as well in decision making. The other one would be government legislation. Okay, so there might be some legislations. Okay, so which prohibits the use of certain materials. Okay, so in the production, so thus it could affect as well. Okay, so my decision. Okay, so it could affect as well the decision that I need to arrive to. Okay, so after considering so many factors, as well as technological breakthroughs. Okay. So all of these things are the different factors, whether that can be quantified or other factors that would be difficult to quantify. However, it affects the decision process. So all of these things plays a big role in decision making. Okay. So which plays a role. Okay. So for our quantitative analysis. So in quantitative analysis approach, so there are different phases, okay, so that we need to consider, so for us to arrive through a sound decision afterwards. Okay, so we start always with defining the problem. Okay, so what the problem is, and then once it is clear to us what the problem is, so we develop a model. So depending on the problem, so whether we're going to use an LP model, okay, so we're going to use let's say a decision tree, so or are we going to use will this be a network, so that needs a network analysis, and other things. And then, so once we develop a date or the model, so we acquire input data. So we have to consider uh, the factors, or we have to consider mm, raw data. Okay, so whether that would be uh, uh, that would be from the company profile. Okay, so whether that will be the result, okay, of the production output, and so on. Okay, so as long as those are accurate data, so we have to acquire those. And then once we have those data, so we develop a solution. Okay, so we develop a solution, so based on the model and in considering the data as well. And once we were able to develop a solution, okay, so to our problem, a solution to our problem, so should be tested. Okay, so it should not be right away be implemented. Otherwise, so it could affect, okay, a certain company. So we have to test the solution first. And once the solution is already feasible, so we have to analyze the results of the testing. Okay, so whether that is feasible or not. And then, so once we are already sure, so whether the solutions are already feasible, and that's the time that we should be implementing the results. Okay, so that is how the quantitative analysis approach happens. Okay, there are cases that, for example, that's just the waterfall model. Okay, so from defining the problem until the implementing the results. However, there are cases that so once we develop a solution and then we tested the solution, and it appears that it's not feasible. Okay, so it's not feasible to so during the testing process. So, like for example, so we were able to identify that this should be the raw material that we will be using. Okay, so that this is the raw material that we will be using. So based on our analysis, however, it's just so happened that that raw material is not available. Okay, so there is a or there is or the raw material uh, is probably costly, or probably uh, there are some restrictions. Okay, so from the customs, that's why you cannot process it, or you cannot receive, okay, the given raw material. If that is the case, then we have to go back, okay, so to our model. Okay, probably, okay, so that solution is not feasible. There are cases that during the analysis, okay, so during the analysis, probably the raw material is there. However, I am testing the structural capability of the product. Let's say, for example, it's for civil engineering, and then it just so happened that there is a problem on the structural stability of the product. Then we have to reconsider. Okay, so then we have to reconsider our solution, even though the solution will yield the optimized result. However, there's a problem on the structural integrity of the structure. Then we have to go back. Okay, so to our model. So since safety, okay, so far outweighs the profit, okay, so that we can get out of it. So that is how we do the quantitative analysis approach in decision making. So to be very specific, so we have to define a problem. So most of the time, so once there is a problem, so we have to pinpoint, okay, so whether that is really the problem or not. There are cases that what we are finding is just a superficial problem, but that's not the root cause. Okay, so that is why even though we keep on doing things again and again, like for example, there is a in a production line, so there is a low output. Okay, so there's a low output in the production line, and then we keep on thinking that the problems are the people, or okay, the manpower. Okay, they are not doing their job well, so that's why we are not producing the right output that we want, or the number of output that we want. That is just based on our hunch. Okay, so that is just based on other things, but uh, is that really the problem? Okay, so we have to think. So we have to analyze our data. Okay, probably it's not the people that's the problem. Probably the problem is the process. Okay, that you need to improve to. Okay, probably the machines. Okay, so that are available under the production lines, so the one that's having the problem. Then that's the one that we need to solve. Okay, so in every decision making that we or in every decision that we need to make, so we have to really define if that is really the problem. Okay, because that's the most important one. We might be focusing on solutions. Okay, so we might be focusing on solution wherein in fact that is not the problem that needs to be resolved. Okay, so, in developing a or defining a problem, so we should develop a clear and concise statement that gives direction and meaning to subsequent steps. So, the first one, this may be the most important and difficult step, so which I keep on saying. So, it is essential to go beyond symptoms and identify true causes. Okay? So, it may be necessary to concentrate on only a few of the problems. So, selecting the right problems is very important. So, we don't need to address all the problems. Okay? So, we just need to pinpoint, okay, so which are the most prominent one, and there we focus. Okay? So, there we try to find solution for such problems. And lastly, so we have to be specific, and there should be some measurable objectives so that will be developed. Okay, so how do we address problems? Uh, so we need to have key index, okay, so that are measurable. So for us to determine so whether we were able to attain or resolve such problem or not. So once we were able to identify the problem, okay, so that's the time that we develop a model. So developing a model, so through different approaches, okay, so from linear programming, nonlinear programming, network analysis, game theory, or even decision tree, okay, we can develop a model, okay, so that could represent a certain problem. So through, like for example, with this one, so we could just represent this one into a linear model. So we're in the yield or the output or the sales. Okay, so the sales increases as number of advertisement increases. Okay, so we just have to develop this model so for us to later on so understand how uh, the different variables play together. Okay, so we'll be able to understand how are we going to resolve such problem. Okay, so there are different approaches on how to create a model. So we have to understand what will be the mathematics behind it. But later on, so more than the mathematics, so what does it mean, uh, or what does it mean, or what does it emphasizes? So that is what we need to remember here. And once we were able to develop the mathematical model, so there should be or data. Okay, so data should be acquired So data should be accurate in as much as possible. Because remember, okay, so we have the garbage in, garbage out. Okay, so we have if we have a garbage. Okay, so if we have a garbage data, then we expect that we have a garbage output. Okay, so that is why in every decision making, so it should be based. Okay, even in forecasting. In forecasting, we need historical data. Okay, so in if we want to improve the output in a production line, so we have to look at the production. Okay, so the production data. Okay, so uh, from those available data, so we or from those accurate data. Okay, so will be able to arrive through a certain decision. So data may come from a variety of sources, so such as company reports, company documents. Okay, so we can even interview. Okay, so aside from the actual data based on the reports, so we have, especially if we are dealing with people, okay, so we could interview. Okay. There could be some problems, okay, so which are not seen, okay, on the numbers based on the reports. Uh, because okay, in a production line, people who works there do have their feelings. Okay, so they might not be uh, that inspired. Okay, so to do their work. So things like that so can only be taken so through interviews. Okay, so on-site direct measurement as well as statistical sampling. And once we were able to acquire the data, so we are going to develop a solution. So based on the mathematical model that we had, and then we develop a certain solution. Okay, so solutions can be arrived into, okay, or the best or the optimal solution can be arrived into so through different techniques. So we could do solve equations. Okay, so we can solve equations. Once we have all the data, we can do trial and error. Okay, so if we are having difficulty creating the mathematical model, so we can do trial and error. So we try this approach. If it works, then continue it. If it does not work, then we try to revise it until we will able to arrive to the best result. And then complete enumeration. So we try all the possibilities, and then based from all the possibilities, so which is the best one. And lastly, so we can even use some algorithm. We can even use programs. Okay, so to make decisions for us. Okay, so we have the QM. Okay, solver from the Excel. So we could use some applications. Okay, so for decision makings or for us to develop a certain solution. And then, so once we have the solution, then we test the solution whether it works or not. So both input data and the model should be tested for accuracy before analysis and implementation. We do not right away implement our solution. Okay, so we test it first. Okay, so whether the result is accurate or not. Okay, so new data can be collected to test the model. So once we were able to develop the model, and then we're going to test it based on new data. So whether the model still holds true, so given those data. And results should be logical, consistent, and represent the real situation. So once we tested the solution, so we analyze the results. So determine the implications of the solutions. So implementing results often requires change in organization, especially if our solution would be in terms of manpower. Okay, so if our solution is to change uh, the time, okay, the work time of the different personnel, and probably, okay, so there could be some reorganization that would be needed. Is there really a need, okay, so for reorganization, or as I mentioned, is it just the process that is having the problem? And lastly, so we have the impact of actions or changes needs to be studied and understood before implementations, especially if you are working with people. Okay. So in terms of machine, it would be it's easy. Okay, so whether we're going to use this machine over the other, but when it comes to people, okay, so we have to consider other factors as well, especially humanitarian factors. And lastly, so once everything is already good, so that's the time that we implement the results. So implementation incorporates the solution into the company. But we have to be very open, okay, that implementation can be very difficult, especially if this is the first, uh, if that's the first time to do it, okay. So there are a lot of people who opposes changes in the company. However, we have to balance, okay, so we have to balance so whether uh, we are still achieving, okay, so the things, okay, so for the company, and at the same time, so we just have to balance it out with the needs of the people, okay, so that are working for the company. So many quantitative analysis efforts have failed because a good workable solution was not properly implemented. Okay, so there are cases that the solution is good. However, the implementing rules and guidelines on how to do the solutions is not good. Okay, so that's the time that we are experiencing some problems. So lastly is how to develop a quantitative analysis model. We could have as simple as this. Okay, so a mathematical model of profit. So profit is equals to revenue minus the expenses. Okay, because of course we do things, we want to gain some profit. Uh, on how to develop the model, so the profit is equals to the revenue, so minus the expenses. However, for the expenses, so there are fixed costs, so which are usually the machines that we use, okay, so the services that we need, okay, so for us to deliver or to develop that product, plus the variable cost. So what would be it could be the raw material for us to produce that product or that service. And so for our profit, so that's just simply, or for the revenue, so that's just the selling price per unit. So multiply it with the number of units sold. So minus the fixed cost. So plus the variable cost per unit, so times the number of units sold. So this would be our uh, profit model. So S is the selling price per unit, X is the number of units sold, so F is the fixed cost, and V is the variable cost per unit. So we have a simple example here, so where we can use the profit model. So the company buys, sells, and repairs old clocks. So rebuilt spring sells for $10 per unit. So fixed cost of equipment to build springs is $1,000. So variable cost for spring materials is $5 uh, per unit. So let's try to see uh, so how this one works. Okay. So this company buys, sells, and repair old clocks. Okay. So once they rebuild the clock, so they could sell that one for $10 per unit. But the cost for spring material so that they need, okay, so to rebuild a clock, so would cost them $5 per unit. And at the same time, the equipment, okay, so to build the springs cost $1,000. Okay, so based on the given, so we have the selling price of $10, and then we have the fixed cost, so which is $1,000, and then the variable cost, which is uh, $5. Actually, there's no problem here, but rather, so let's just try to analyze this one. So let's say, for example, if I'm going to build uh, I'm just going to create, let's say 20. Okay, so if I'm going to create a 20 units, and the other one would be 200 units. So what would be the profit? So for our profit, so that would be equal to the selling price. So multiply it with the number of units. So minus the fixed cost. So plus the variable cost times the number of units. So for letter A, if there are 20 units, so the profit then will be, so selling price is $10. X would be 20, then minus 1,000. So plus V is 5. X would be 20. Is that correct? So X is 20. So P then would be, this is 200 minus 1,100. So that would give us a profit of negative 900. So that means if I'm just going to produce 20 units, okay, so I was not able to regain. Okay, so my investment for $1,000 for the equipment. However, if I'm going to produce 200 units, so that would be 10. So times 200 minus, let's say I'll have 1,000. So plus 5 times 200. So this would be 2,000. So minus 1,000 plus 5 times 200 is 1,000. That would be 2,000. So the profit will be 0. Okay. So that means I need to produce. Okay. So I need to produce 200. Okay. So 200 units for break even. Okay. So I did not gain a profit. Okay. I did not lose a profit as well. So that is why uh so for me to get the break even point, so the profit should be 0. Okay, so if the profit is 0, so then I have S times X minus F plus VX. And so let's say I have SX minus F minus Vx, and then I'm going to factor out X. I have S minus V, S minus V, and then minus F. So let's say I have F, X, S minus V. So therefore, X then will be F over S minus V. So if I need to want to determine, okay, so the break-even point, so I'll have this formula. So that would be the fixed cost. So divided with the selling cost minus the variable cost. Selling price minus the variable. Okay, so the BEP or the break-even point is this one. If my profit will be 0. So if I'm going to produce more than 200 units, so that's the time that I'll be gaining some profit out of it. Okay? So that is all about the quantitative analysis. So the next video will be about linear programming.